Assalamualaikum and good day to Miss Nazira. Today, me and my group member will present to you about salicylic acid for course under the code CHM301 Organic Chemistry 2. So, before we start our presentation, let me introduce to you our group member. The first member is Ifa, the second one is Amni, the third one is me, Patricia, and the fourth one is Amaline. So, this is the content in our presentation. We do include introduction that will be presented by Ifa, physical and chemical properties will be presented by me, Patricia, benefit and uses of the compound will be presented by Amaline, while chemical reaction and conclusion will be presented by Amni.
Hello everyone, welcome to our presentation. To kick things off, I'll be introducing a very interesting and important organic compound that's not only found in nature, but also plays a major role in skincare and medicine, salicylic acid. Salicylic acid, also known by its Iopad name 2-hydrobenzoic acid, is a white crystalline compound with powerful antibacterial and anti-inflammatory properties. Chemically, its structure includes a benzene ring with two key functional groups, a hydroxyl group and a carboxylic acid group. This group makes the compound very reactive and useful in both natural and medical settings. You might not realize it, but this compound naturally exists in the bark of willow trees and in wintergreen leaf. In plants, it helps defend against infection. For humans, it's one of the most common ingredients used in acne treatments, chemical peels, and anti-dandruff shampoos. Continue in this slide, I will tell you about the background of salicylic acid. What makes salicylic acid even more fascinating is its long history. Thousands of years ago, ancient people like the Greeks and Native Americans used willow bark to reduce pain and fever. Without even knowing it contains salicylic acid. The word salicylic actually comes from salix, the Latin name for willow. Later, scientists transformed it into a more stable form which we know now as aspirin, one of the most famous and widely used medicine in the world. And here's a fun fact. Plants use salicylic acid like a defense alarm when they were under attack by pests or disease. This molecule helps trigger their immune response. Plus, tiny amounts of it are naturally present in everyday foods like tomatoes and berries. So, to summarize, salicylic acid is not only a plant protector, but also a skincare hero and the origin of aspirin. Its natural roots and powerful properties make it a perfect example of how chemistry connects plants, people, and modern medicine. With that, I will now pass it over to the next presenter that will introduce more about salicylic acid.
Now, I will explain about the physical properties of salicylic acid. First, the chemical formula of salicylic acid is C7H6NO3, while its molecular weight is 138.12 gram per mole. In terms of appearance, it is a white crystalline powder. The melting point is between 158 to 161 degrees Celsius. Next, the boiling point of salicylic acid is 211 degrees Celsius and it decomposes at this temperature. It has a slightly phenolic odor. The density of salicylic acid is 1.44 gram per cubic centimeter. For solubility, it is slightly soluble in water and freely soluble in ethanol and ether. Now, moving on to the chemical properties. Salicylic acid shows acidic nature because it contains both a carboxylic acid group COOH and a phenol group OH, making it a weak organic acid. It also undergoes esterification, where it reacts with alcohol to form ester, such as methyl salicylate. Furthermore, salicylic acid is involved in aspirin formation. It reacts with acetic anhydride to form acetyl salicylic acid, which is commonly known as aspirin. Besides that, The phenol group can be oxidized under strong condition. And lastly, under strong heating, salicylic acid undergoes decarboxylation, where it loses a carbon dioxide molecule and forms phenol.
Now, let's move on to the benefit and uses of salicylic acid. Salicylic acid is known for its wide range of skin benefits, especially for acne prone and oily skin. First, it's worked by unclogging pores. Since it's oil-soluble, it can go deep into the skin and dissolve the oil and dead skin that block our pores. Next, it treats acne effectively, particularly blackhead and whitehead. It reduces inflammation and redness in pimples, helping them to heal faster. It also works as a gentle exfoliator. Unlike physical scrub, it removes dead skin chemically, which is safer and more effective, especially for sensitive skin. Another benefit is that it controls oil production. It reduces as a sebum without drying out the skin too much, making it ideal for those with oily and communication skin. Finally, salicylic acid helps improve skin texture. With regular use, it can make the skin smoother, reduce pore size, and even out skin tone. Salicylic acid is commonly used in various skincare and medical products. Firstly, it's a popular ingredient in acne skincare products like face washes, toners, and spot treatment. These help prevent and treat breakout by targeting clogged pores and inflammation. Secondly, we often see it in exfoliating treatment, such as chemical peels, masks, and pre-soak pad. This removes dead skin and help with issues like dullness and rough texture. In haircare, salicylic acid is found in anti-dandruff shampoos. It exfoliates the scalp, removes flakes, and soothes irritation caused by conditions like seborrheic dermatitis. Lastly, it's also used in medical treatment for warts, corn, and calculus. In this case, stronger concentration of salicylic acid are applied to soften thickened skin for easier removal. So, as you can see, salicylic acid is a very versatile ingredient with both domestic and medical uses. Besides skincare, salicylic acid also plays an important role in modern medicine, especially through its derivative, aspirin or acetylsalicylic acid. Aspirin is chemically made by adding an acetyl group to salicylic acid. This small modification creates a new compound that less irritating to the stomach but still keep many of their original benefits. In fact, aspirin was first developed to make salicylic acid easier to tolerate as a medicine. So, they are directly connected in both structure and history. Now, let's look at the benefit of aspirin. First, it widely used as a pain reliever for headache, muscle pain, and inflammation. Second, aspirin has anti-inflammatory and fever reduction effect, making it useful for conditions like arthritis or viral infection. One of its most important uses today is in heart health. Low-dose aspirin is prescribed to reduce the risk of heart attack and stroke because it helps thin the blood and prevent clot formation. Some studies also suggest aspirin may help reduce the risk of certain cancer like colorectal cancer, although this is still being researched. So, as we can see, salicylic acid is not only powerful in skincare, it also forms the foundation of one of the most widely used medicine in the world.
Now, let's talk about the chemical reaction that salicylic acid can undergo. There are three types of chemical reaction. The first one is esterification, neutralization, and acetylation. Esterification is a reaction between carboxylic acid and alcohol under reflux to produce ester. The reaction needs the presence of a strong acid like the concentrated sulfuric acid to make the reaction even more faster. Now, as you can see in the slide given, carboxylic acid part of the salicylic acid will react with methanol, which is the alcohol, with the presence of concentrated sulfuric acid will produce methyl salicylate and water. Carboxylic acids undergo neutralization reactions with strong bases or even some weak base to form carboxylic salts of carboxylic acids and water. As you can see in the slide, we have given you the chemical equation, which is the carboxylic part of the salicylic acid will react with the sodium ion of the sodium hydroxide, which is the strong base, will produce sodium salicylate and water. Acetylation is when the hydroxyl part of the salicylic acid react with the acetyl group, which in the slide we are using acetic anhydride to produce acetyl salicylic acid, which we all know as aspirin and acetic acid. In conclusion, salicylic acid is a really interesting and helpful compound. Its special features and how it acts chemically allow it to do many useful things. We find it in medicine for pain and skin problems, and it also important for making other chemicals. Knowing how it reacts, it helps us understand more about chemistry. Therefore, salicylic acid remains as one of the very important and significant molecules in science and in our daily life.